It's Algebra 1, Spring Test number 6 study guide. First two tell you to solve the inequality, then graph the solution. So we have the absolute value of, in this case, d plus 2 is greater than or equal to 6. Remember, anytime you have absolute value, you're going to make two problems out of it. The first one, d plus 2 is greater than or equal to 6. You make it look just like it does in the problem without the absolute value symbols. The other one, d plus 2, that stays the same. You're going to reverse the symbol. Greater than or equal to becomes less than or equal to, and you're going to change the sign from positive 6 to negative 6. So we have two problems right here. D plus 2 is greater than or equal to 6, and D plus 2 is less than or equal to negative 6. So undo for both of them plus 2, so minus 2 here and here. So D then, and I'll write it back in red, D then is greater than or equal to 4. The other one, same thing, subtract the positive 2. D is less than or equal to. Those are the same signs, so add them up. 6 and 2 gives you 8, and keep that common sign negative. So that's both of them solved out. D is greater than or equal to 4, and it's or. Anytime you have a greater than from the beginning, this right here, it's or. Another way you can determine it is when you graph it. I'll show you in a second. Or D is less than or equal to negative 8. When we graph both of those, we'll graph them on the same number line. You only need to include two numbers, the two numbers you're dealing with, negative 8 and 4. Remember, this is a negative number, so it'll be there, and 4 will be there. Okay, so the first one, D is greater than or equal to 4, is a colored in bubble at 4, and everything that's greater than, everything to the right. The other one, D is less than or equal to negative 8. That is a colored in bubble, and everything less than or to the left. And there is your graph to match your inequality. Less than or equal to negative 8, greater than 4. The second one says the absolute value of 2x plus 6 is less than 18. Again, it's an absolute value inequality, so we'll say 2x plus 6 is less than 18, just like it's written without the absolute value symbols. This time it's an and inequality because, yeah, it's an and inequality since it's less than. The other inequality will say just like that, 2x plus 6, that part doesn't change. But less than becomes greater than. That inequality flips, and positive 18 becomes negative 18. So you have to solve both of these inequalities. Undo plus 6 for this one right here by subtracting 6 on both sides. 2x, no reason to reverse it. 18 minus 6 is 12. And then get x by itself by dividing by 2 on both sides. X is less than 6. X is less than 6. For the other one, undo plus 6 again by minus or subtracting 6. No reason to reverse it. 2x is greater than negative 18 minus 6. Those are the same sign. So add them up, you get the number 24 and keep the common sign negative. And then get x by itself by dividing by 2 on both sides. X is negative 24 divided by 2 is negative 12. There's no reason to reverse the symbol here because you're dividing by a positive number. The fact that it comes out to be negative doesn't matter. So right here we have two inequalities that we need to create a compound inequality. So put your smaller number first. Negative 12 would be smaller than 6. So we'll put it up front right there. And make the symbol go the same direction. So as a compound inequality, negative 12 is less than x and less than 6. So when we graph that, graphing it's easier typically. We'll have negative 12 and we'll have 6. There's no other numbers you really need to include. X is less than 6. This time it's an open bubble showing less than everything that way. And x is greater than 12, negative 12, again, an open bubble, greater than everything that way. Notice the overlapping area between negative 12 and 6. Number 3 says X minus 1 is less than or equal to negative 9. So there's no absolute value here. We simply undo minus 1 by adding it to both sides. X is less than or equal to negative 8. So we only have one number we have to deal with here. So when we graph it, include 0 just as a reference point. 0 is there. Negative 8 is on that side. 0 and negative 8. So less than or equal to is a colored in bubble, and less than is that direction. The next one, x over 7 is greater than 9. That says x over 7 or x divided by 7. Undo divide by 7 by multiplying by it, and do the same to the other side. X, 9 times 7 is 63. All we did was multiply by a positive number, so leave the symbol going the same way. X is greater than 63. Again, a reference point 0. 63 is on the right side of it. Greater than is an open bubble, and everything to the right is greater than. Number 5 says negative 10 is less than or equal to 2x minus 4 and less than 10. This one has a left side, a middle side, and a right side. So if you need to separate it where you can see them, do that. And you're trying to get x all by itself in the middle. So 2 is multiplying by x, and 4 is subtracting from that. So you undo your order of operations backwards. You undo addition and subtraction first by undoing minus 4 using plus 4. If you do it to the middle, do it to the right, and do it to the left. So negative 4 plus 10 is negative 6. 2x will be by itself in the middle, and 10 plus 4 is 14. There's no reason to reverse the symbols because all we did was add 4 to everything. So this one's going to stay as less than or equal to, and this one is going to stay as less than. Then get x by itself in the middle. It says 2 times that. Undo that by dividing by 2. Again, if you do something to the middle, do it to the left, divide by 2, and the right, divide by 2. Negative 6 divided by 2, opposite signs, is negative 3. And 14 divided by 2, same signs, is positive 7. We divided by positive numbers, so again, you only multiply and divide by a negative number. That's the only time you change the signs or reverse them. So we'll leave less than or equal to, and we'll leave less than right here. So this is your solved inequality. Negative 3 is less than or equal to x, and less than 7. Again, you need to show two numbers. You need to show negative 3, and you need to show 7. Make sure you have them on the appropriate sides. Don't have 7 on the left side of negative 3. So x is less than negative 7. That's this one here, the one that you can read it from the variable very easily. Less than is an open bubble, and less than is everything to the left. The other one, x is greater than, if you have to rewrite this one in a different order, if you have to rewrite it with the x first and the negative 3 on the other side, just make sure the big mouth is eating the x to where you can see it, just to make graphing it easier. It's greater than or equal to negative 3, which means you color the bubble in, and it's everything going this way. Notice the overlap between negative 3 and the 7. Remember, when you have an and inequality, or you have an inequality where x is in the middle, you're going to have overlap. That being said, number 6 is the same. You'll have the same overlap for this one. If you need to, again, draw your two lines and put x right in the middle. That's what we're trying to get. Undo minus 8 by adding 8 to the middle, the left side, and the right side. Negative 4 plus 8 is positive 4. 4x is still in the middle, and 4 plus 8 is 12. No reason to reverse the symbols. All we did was add it there. Undo 4 times x in the middle by dividing it. You do it to the middle, do it to the left and the right as well. 4 divided by 4 is 1. 12 divided by 4 is 3. And again, all we did was divide it by a positive number, so we'll leave the symbols in the same direction they already are. Show the numbers 1 and 3 again. Make sure you have them appropriately on the right and the left. This one is the easier one to graph right here. X is less than 3, an open bubble and everything that way. The other one, again, if you need to reorder this one and put the x first and then the 1, make sure the big mouth eats the x. And then x is greater than, again, an open bubble, everything that direction. And again, notice the overlap between numbers 1 and 3. Number 7 says write an inequality for the situation. All real numbers k that are less than negative 7 or greater than 7. So we're just using k instead of x. So we're going to have one of them that says k is something negative 10. The other one's going to say k is something 7. We need to come up with what those somethings are. It says k that are less than negative 10. So k is less than negative 10, or k is greater than 7, so greater than 7. Again, an or inequality is simply going to have the word or in between, both of them written side by side. K is less than negative 10, or k is greater than 7. Number 8 says to solve the compound inequality and graph the solution. So the same thing we were doing a minute ago, except these are not and inequalities. This is an or inequality. So solve them as two separate ones. This one here first. Want to get x by itself, add 6 to both sides. Negative 16 plus 6 is negative 10 here. We still have 5x, and there's no reason to reverse the symbol. Divide by 5 on both sides. X is negative 2. And then again, we divided by a positive 5. There's no reason to reverse the symbol, even though it comes out to be negative 2. Or the other one, we'll do the same thing to get x by itself. Subtract 1 here and here, and 6x is greater than negative 5 minus 1. Same signs, add them up and keep the common sign negative, negative 6. And then get rid of 6 times x by dividing by 6 here and here. Negative 6 divided by 6 is negative 1. And again, the fact that it comes out to be negative is irrelevant. It divided by a positive on both sides, so you'll leave the symbol look just like this. So this is the or inequality solved out. X is less than negative 2, or x is greater than negative 1. And again, you want to show two numbers. You want to show negative 2 and you want to show negative 1. And then we'll graph both of them separately and just combine them. So x is less than, open bubble, negative 2, everything that way. X is greater than, again, open bubble, everything that way. They're open bubbles because it does not say or equal to with it. Number 9 says to solve these equations. If there's no solution, write no solution. The absolute value of x minus 7 is equal to 6. Remember, before we try to undo what's inside that absolute value symbol, we have to simplify that whole side, or get on that left side of that equation, get the absolute value all by itself. So what we want to do is undo our order of operations like we always do. Undo addition and subtraction first. So get rid of this minus 7 by adding 7 to both sides. 6 plus 7 is 13 on that side. So you have the absolute value of x is equal to 13. So remember, absolute value simply talks about a distance away from 0. So it's saying that what number is 13 away from 0. We know that there's a left side and a right side to 0, a negative and a positive, respectively. So x is both equal to positive 13 and x is equal to negative 13, both directions of 0. For number 10, 5 times the absolute value of n minus 10 is equal to 35. Again, before you get the absolute value by itself, or before you try to undo that, you need to work your order of operations backwards. Undo minus first. Minus 10 plus 10 cancels it out. So 35 plus 10 is 45 on the right. So we have 5 times the absolute value of n. Again, before you get to the absolute value, that works in the same step as a grouping symbol or parentheses. That's the last thing you have to undo. We need to undo this 5 times that by dividing by 5. You do it to the left, do it to the right. 45 divided by 5 is 9. Now we have the absolute value of n all by itself. We have it isolated. So n is both how far away from, or this number is 9 away from 0. Remember the left side and the right side of 0. So both 9 and negative 9 are that far away from 0. Number 11 says 2 times the absolute value of x plus 3/4 is equal to 6. Again, before you set it equal to both positive and negative, like we did on the previous two problems, you need to simplify. You need to get the absolute value all by itself. So we need to divide by the fact that it says 2 times that. Divide by 2. You do it to the left again, do it to the right. Now it leaves you with the absolute value of x plus 3/4 is equal to 6 divided by 2 is 3. Now we have the absolute value all by itself. So since we have that, we want to make two problems out of it, just like we did on the previous two, except we have one more step to do after it on this one. The first one, x plus 3/4 is equal to 3, just the way it's written without the symbol to go with it. The other one, x plus 3/4, that's still the same, but now it's equal to negative 3. So you want to solve these two simple equations to get x by itself. So for this first one, to get x by itself, we want to undo plus 3/4 by subtracting 3/4. If you subtract it on the left, subtract 3/4 on the right. So just to make the fractions easier, 3 minus 3/4 leaves us with 2 and 1/4. So one of them is 2 and a fourth. Again, we'll do the same thing just to make the fractions easier. Subtract by 3/4 here and here. Remember, both of these are negative values, so we're going to add them up. 3 plus 3/4 is 3 and 3/4. And since they were both negative, that's the sign we'll keep. So x is equal to 2 and 1/4, or x is equal to negative 3 and 3/4. Then we have to graph these inequalities. This is the first time we've dealt with graphing inequalities with two variables, y and x. Notice that this is written in y is equal to mx plus b form. So that's a form that we like to graph. If it had just said equals instead of less than in the middle. B tells us where to begin. Begin at negative 2 right here. M tells us where to move. Remember, M is always a fraction, even if it doesn't show you one. So it's 5, which in order to make it into a fraction, we know we have to put it over the number 1. 5 over 1 means rise over run. It means go up 5 and to the right 1, since they're both positive. So from that 2 we just made, we're going up 1, 2, 3, 4, 5, and to the right 1 time. There is our second point. If this were just an equation, we would draw a straight line through this and we would be done with this problem. This is not just an equation, though. It is an inequality. So the first difference that you need to do for inequalities, you have to decide if the line will be a dashed line or a solid line. In order for you to decide which one's which, it has to say or equal to make a solid line. Right now, it just says less than, so we will make between these two a straight dashed line between these 2 points. Hopefully a little straighter than what I just did on the screen. The second difference is we need to shade everything on one side of the line or everything on the other side. You want to pick any point on the whole plane that does not fall on the line itself. The easiest point to pick is the point 0, 0. Okay, you'll know if it goes through 0, 0 because it won't even be close to it like this one is. It'll go directly through 0, 0. The reason 0, 0 is the easiest point to pick is because it's easiest to multiply by it. So if we pick that point 0, 0, even though it's close to the line, we can plug in its x and y value. In place of y, we can plug in 0 is less than 5. In place of x, we can plug in 0 minus 2. Anything times 0 is 0 minus 2. So 0 is less than negative 2. This is where you have to evaluate its truth value. Is 0 less than negative 2? No. The bigger number in this case is 0. Think of where it is on the number line, which means 0, 0 is wrong, which means everything on the same side as 0, 0, all of this is also wrong. You shade away from that, then you shade the opposite side to represent the solution.